Welcome, ladies and gentlemen. We're going to be tackling the 2025 AP Calculus AB FRQs. That's going to be only 3 questions in this packet because I kind of want to separate them. But all right, number one, I'm going to assume you guys already read the question. So go ahead and get started. For part A, if you want to find the average number of acres affected, you got to really carefully approach the question. Again, we want to find the average number of acres affected. If you read the question, the equation that they give us, C of t, represents the number of acres in the fruit growth affected. So that's literally going hand in hand with what the question is saying. So you got to think about average value. That word value is interchangeable with whatever the equation represents, right? If they give us an equation that represents height, the question will be asking for average height. If they give us an equation for weight, the equation will be asking average weight. So in this case, they're asking the average number of acres affected, which is exactly what the equation represents. So you got to do average value. 1 over b minus a. We're finding it from 0 to 4 of the integral from a to b of our equation, c of t dt. And because this one is a calculator question, you can just plug it in, giving you 2.778. And don't just give the answer, also give what it means. So we're going to say from t is equal to 0 to t is equal to 4, the average number of acres affected I think I spelled it right, by the invasive species is 2.778 acres. Make sure you get your units right. We integrated, so it's just acres. Really careful not to put a right in there. Okay, part B. In part B, we need to find a time when the instantaneous rate of change equals the average rate of change. So they're talking about the mean value theorem, whether or not they say it. So here's your setup. When does c prime of t, the instantaneous rate of change, equals the average rate of change from 0 to 4. And set it up, right? Every time you do a problem, set it up before you do anything. Okay, I don't really need my derivative yet. Even though it is given to me, okay, I'm looking at my notes over here. So yeah, the derivative is given to me, but I can just write c prime of t. And then the average rate of change, plug it into your calculator really carefully. You should be getting 1.282008. You can always cut it off to less decimal places. 3 decimal places rounded would be fine. Well, use your graphing calculator. Graph them, find the point of intersection, and you're going to get that t equals 2.154298. Again, 3 decimal places, okay. And that's your answer. But put it in the context. The instantaneous rate of change. You know what? I'll let you guys finish that. But I'll tell you what it is. The instantaneous rate of change equals the average rate of change at 2.154298. And they don't even tell us if it's weeks, right? Yeah, t weeks. ... 2.154 weeks. Okay. Part C. So here, they want us to write a limit. I'm not writing the full question, but I'm assuming you guys have. Write a limit expression that describes the end behavior of the rate of change of the number of acres affected. Okay, if C of t represents the number of acres affected, this is just for you guys, right? Like I wouldn't actually write that part down on my test. It's just something that you just kind of need to go with. If that's the number of acres affected, then the let me go back to the question. Okay, the rate of change in the numbers of acres. That's basically talking about the derivative. That's the rate of change of the number of acres. Basically what I wrote up here, right? All right, so we got to write a limit expression just to say the end behavior. It's actually not that bad. You just say the limit as t approaches infinity of the rate of change of number of acres affected, blah, 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 and then actually take the limit. You know what? I'll do it down here. The limit as t approaches infinity of 38 over 25 plus t squared equals 0 because it's small over big. There it is. Everything that I'm doing, make sure to write it yourself because you get a point for the limit and you get a point for writing the limit expression. But this one is okay too. Let me go back to part B. You get a point for setting it up, saying that the instantaneous rate of change equals the average rate of change. You get another point for the answer with the context. In part A, you get a point for setting up your average value, and you get a point for the answer with the context. Okay, last one in question 1. Let's see. So we got 4 weeks. Okay. The invasive species. I guess I gotta read the question to myself too. After the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function A models the number of acres. Models the number of acres affected by the species. Blah blah blah. At what time does A attain a maximum? Okay, perfect. That's all I need. When does A attain its maximum? What do you know about maximums? Take the derivative. Now, the derivative of c of t is c prime of t. And the derivative of that integral, okay, remember your fundamental theorem of calculus here. Basically cancel out the integral and plug in the limit of integration, the variable limit of integration. So that's my derivative. Get your derivative, set it equal to 0. Multiplication here. Hopefully you don't confuse us as decimals. Yeah, and then graph it. We already have c prime of t. It's given to us. And then plug it into your calculator, find your x-intercepts. That's going to be 11.4417. This is my critical point, guys. This is not the answer. If you want to find the absolute maximum, you got to test all the critical points. And you got to test your endpoints. So my endpoints, they want me to find the maximum between the interval from 4 to 36. So 4 and 36. And we also have to test our critical points. Where do we plug them in? We plug them in into A of t because we want to find the maximum number of acres affected. All right. So I'll show you what it's going to look like. Basically, you're going to plug in the 4 into C. So C of 4 minus the integral from 4 to 4 of 0.1 ln of x dx. You got a calculator with you, plug it in. This gives you approximately 5.128. And you plug in your critical point, you're going to get 7.316978. And don't just copy my numbers. You should actually try at least one of these to make sure you know how to work the calculator. It's really easy to make a mistake. If you feel confident with one of them, then at that point I would say maybe save your time and just move on. But make sure to get at least one of them right. Well, those are my values. The maximum. A attains its maximum value at t equals, well, I guess it was our critical point, 11.4417. There it is. For this question, you're going to get 1 point for the conclusion. You're going to get 1 point for taking the critical points and the endpoints into consideration. And you're going to get 1 point, I believe it was for taking the derivative and making it equal to 0. But yeah, that's question number 1. Let's see. I'll do this one later. Right now, I'm going to tackle the AB questions that are shared with the BC test, which should be this one, number 3. No calculator. Okay. So we got a student reading the book. We got a table of values here for R of t, which represents word per minute. Really important because that means we're dealing with a derivative, even though we don't have the prime symbol. Okay. Approximate R prime of 1 using the average rate of change over 0 to 2. Okay, it's not too bad. R prime of 1 equals R of 2 minus R of 0 divided by 2 minus 0. If you look at your table, R of 2 equals 100, R of 0 is 90, which means we get 5. Put your answer into the context. At t is equal to 1 minute, the student is reading 5 words per minute. Minute. Okay, I confused myself there. The words were a little too close to each other. So the units are important. You're gonna get 1 point for getting the correct units. You get 1 point for doing the average rate of change. The setup might be enough. I gotta check the rubric, or it might actually be the 5. It's one or the other. But again, the table of values, right? It was words per minute, and you're doing average rate of change. You're basically doing, in a way, a derivative. So really, really careful with that. Easy points if you don't mess up the units. Part B. Is there going to be a value C where R of C equals 150? That right there, talking about a value in between, is activating the intermediate value theorem. So, well, let's just actually analyze our table before I do anything. Is there going to be a value where we hit 155? Well, if you focus on R of 8 and R of 10, we have like a lower bound and an upper bound. So yeah, because this function is, let's see, did they say it was differentiable? The rate at which the student reads is modeled by the differential function. Okay, sorry for all the glitches. Differentiable function. So yeah. All right. Here's my conclusion. Yes. Since R of t is differentiable, thus continuous, and since R of 8 equals, made a mistake here, 150, and R of 10 equals 162, yes, there is a C value. Here, I'll put it in quotation marks because too many single letters right there. There's a C value such that R of C equals 155 it was. Oh, and finish by saying by the intermediate value theorem. By the intermediate value theorem. Okay, but in order for me to use it, I did have to state that the function was continuous. And then, of course, I had to set like an upper bound and a lower bound. All right. For this question, you get 1 point for saying that part that is going to be continuous, and you get 1 point for the rest of the statement, including the addition of the intermediate value theorem. C. Use the trapezoidal sum with 3 subintervals to approximate the integral. Okay. I can put that here. C. The integral from 0 to 10 of r of t dt equals, and remember your trapezoidal formula. It's basically a plus b over 2 times the height. And you're going to do that a bunch of times. So a and b, here, I'll show you right here. When you have a graph, something like that, I don't know, and you make a trapezoid, let's say from here to here, and you connect them, a is the y value, b is the y value, and the height is the change in x. Okay, so a and b are the y's, the height is the change in x. So if you look at your table, your first y value, your a, is 90. The second one is 100. And the height is the change in x. So basically 2 minus 0. Plus the next trapezoid. A is now 100, b is 150, and the change in x is 8 minus 2. For the final trapezoid, we got 150 plus 162 over 2, and then 10 minus 8. Okay. So here, I already did my calculations, so I'll just tell you what I got. I got 190 plus 750 plus 312, which equals 1,252 words. Okay, now the conclusion. Words read over 10 minutes. This, oh, I didn't even mark what you get points for, guys. 1, 2, 3, 4, 5, 6, 7. But you do get 2 points out of this. I'm pretty sure one of them is going to be the trapezoidal form, and the other one's going to be the answer. Okay, last question. Okay, a teacher. Okay, and now the teacher starts reading also at time 0, and the rate at which the teacher reads is w of t. There we go. How many words has the teacher read? See, there's a lot of words in the problem, but make sure you look at the key statements. How many words has the teacher read? Well, to do that, all you're going to do is the integral from 0 to 10 of wt dt. But because we actually have to do it, and we don't have a calculator, I'm going to write out the formula for wt. And I just got to do your antiderivative. You add 1 to the exponent, and you divide by the new exponent. I'm going to put that 3 that we're going to divide by, I'm going to put it here next to the 10 because there's already a division there. So there it is. Plus, okay, 18. You add 1 to the exponent, you divide by the by the new exponent. I was thinking of the answer already. Plus 100t evaluated from 0 to 10. Before you plug anything in, let's simplify. These cancel, these reduce. Negative 1 over 10 t cubed plus 4t squared plus 100t evaluated from 0 to 10. Negative 10, negative 1 over 10. 10 to the power of 3 is 1,000. Or 10 to the power of 2 is 100. And 100 times 10 is 1,000. Minus, and if you plug in 0, you're just going to get 0. Well, this gets us negative 100 plus 400 plus 1,000 equals 1,300. That is how many words the teacher read. After 10 minutes. Okay, and we get 3 points for this question actually. 1 point for setting up the integral, 1 point for getting the correct antiderivative, and 1 point for the answer with the context. All right, last one, number 4. This is the last question that the BC and the AB test they share in common. All right, so here we have a continuous function. I see a lot of shapes, so yep, we're going to be doing some integrals here. G is the function defined by that integral. Okay, and this is the graph of f. Keep that in mind. Part 1, find G prime of 8. Look, I'm going to start by first writing G of x. G prime, fundamental theorem of calculus here. When you take the derivative of the integral, it cancels it out, and you have to plug in the upper limit of integration, the variable, into the function. So G prime is equal to f. So if I want to find G prime of 8, I also have to find f of 8. That I can do on the graph. F of 8 is 1. Which means that G prime of 8 is 1. You get 1 point for the answer, and you get 1 point for applying the fundamental theorem of calculus. B. Find all values of x where G has a point of inflection. Okay, we already know that G prime of x equals f of x. If you want to find a point of inflection, you need the second derivative. So G double prime equals f prime. Then, to find these values, you got to make the derivative either equal to 0 or undefined. So, when does the derivative, or more specifically, when does f prime equal 0? Since this is the graph of f, I got to look at the slope. So I have a point here, and I have a point here. In addition to that, this point makes the derivative undefined. F prime is undefined. So there's 3 answers. At x equals -3, 3, and 6. And give a little statement why. Because the slope changes signs at x equals -3 and 3. And because the derivative is undefined. The derivative is undefined at x equals 6. You get 1 point for the answer for the values, and you get 1 point for the statement. C. They want us to find G of 12 and G of 0. Let's start with G of 12. G of 12 equals the integral from 6 to 12 of f of t dt. And the integral is the area under the curve. From 6 to 12, we got ourselves a triangle. So here the base would be 6, the height is 3, which means the answer is 9. 1 point for that. G of 0 equals the integral from 6 to 0. To do this, you guys are going to have to flip the integral here. And if you go from 0 to 6, it's a semicircle. So here are my final calculations. Which is -9/2 pi. You get another point for that one. Okay. Let's see if I have enough space for the last piece. Find the value of x where we get our absolute minimum. This is actually pretty similar to What was it? Question number 1? So now you know. Let's find our critical points first. All right, if I can zoom it in. Try to fit it here. D. So we already know if we're going to find the minimum of G, we got to take the derivative. This is the part that we already knew from part A, and we have to make it equal to 0. That happens at -6, 0, and 6. Okay. All right. 6, even though 6 is a critical point, it's not a minimum because G prime doesn't change signs. So I'll just kind of cross it off here. All right. I think my time is running out, so I'll just finish this kind of quick. Just like in the other problem, to find the absolute minimum, you got to take the endpoint, -6, which also kind of happens to be a critical point. Take the endpoints, the critical points, and plug them into G. You are going to have to do this by hand. Look for the first one. It would be like this. It would be the integral from 6 to -6 of f of t dt, which means you have to flip it around. And then you're going to have to calculate that integral using shapes. I'll tell you what the answer is here. C, 0, because of symmetry. Okay. The integral from 6 to 0. Got to flip it around. But didn't we already do this one? We did. And then finally, the integral from 6 to 12 dt. The answer here would be 9. So that settles it. We have an absolute minimum at t is equal to 0 of -9/2 pi. You get 1 point for the answer. You get 1 point for considering the critical points and the endpoints. And you get 1 point, if I wrote this correctly, you get 1 point for setting the derivative equal to 0. Well, yeah. Those are the 3 questions that both the AB and the BC test share in common. I'll see you guys on the next one.